Okay, so this is exactly what we did in Algebra 2. Hopefully this is just a refresher. So if you remember, if you have two logs and they're multiplied together, like log b of x and log b of y, and they're multiplied together, you can break that up into addition. Do you remember this? Do you remember these rules?
Yes.
So if you think about it, multiplication, 4 times 2, is the same as repeated addition. It's just adding the same number that many times, right? So addition and multiplication kind of go together. So this works for logs, and it also works for natural logs. So if I have the natural log of 6 plus the natural log of y, that is going to give me the natural log of 6y. It also works, yeah, for natural logs.
Why is it ln when it's natural log?
So natural logs, the only difference is that a log, so on your calculator, a log right there has a base of 10, and a natural log has a base of e, which is 2.71 something, da 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 da.
Yeah.
Okay? So if it's subtraction, I always remember this, these two straight lines go together. So if you see the division sign, it's subtraction. So same thing here. If I have natural log of x minus natural log of 2z, that would be the natural log of x divided by 2z. And then lastly, the last one is the power property. If it's a power, I can put it out front and it becomes multiplication. Now, this only works because it's a log function. Like, I can't normally take 2 to the 5th and move it out front and do 5 times 2 to get 10. Because 2 to the 5th is what? 32? Okay, those do not work. This only works because you're putting it in front of the fact that you're hitting that log button also. So same thing here. If you have the natural log of xy to the 5th, that is the same as 5 times the natural log of xy. It's all because it's powers. Okay, so expanding and condensing are more for when you get like into higher level math and you need to like add like terms. This is really going to help you. It's also going to help you to know what happens to the graph, okay, which I'll show you on the next page. But hopefully with this first one, you see that there's 3 things. Do you guys see this? There's a 4, there's an x, and there's a y. So when you're writing them out, you have to write a log with each of them. So log of 4 plus log of x squared, yes, plus log of y. And in the condensed version, you always have exponents. So notice you have exponent of 2. And then down here, this is a condensed version. You have a cube root. In the written out version, you kind of get rid of all of those. So like this 2, you have to move that to the front to be absolutely finished with it. It would become 2 log of x plus log of y. And this only works, you can only write it out when all the logs are the same. Do you remember that little rule? Okay. Okay, next one, I'm going down to C. So this, if you get like lost in your head sometimes and confuse yourself, I always just say like baby steps. Well, I see a division sign, so I'm going to just break it up into the log of the cube root of x plus 5 and then minus log of y squared. So it's all about just like starting small and working your way up, and then just keep going. Okay, so they expect you to remember that's 1/3, yes. So x plus 5 is also to the 1/3. Now, when you take this test, it's 40 multiple choice, right? So they might write it as the cube root of x plus 5, or they might write it as x plus 5 to the 1/3. So you just kind of have to know that both are the exact same. I would not mark you down if you kept it as a cube root instead of a 1/3, okay? And then minus, I'm going to move my 2 out front, so 2 log of y. And then I have one last step. Now, I can write this a couple different ways. So 1/3 log of x plus 5 minus 2 log of y. Okay? That's one answer, yep. Or you need to recognize that timesing by 1/3 is the same as dividing the entire thing by 3. So I could write that. So like when you're on an exam, just know that when you look at the multiple choice answers, they both work. Like they're both correct. Come on, Gavin. Okay. Expanding. How are you guys feeling about this? Do you feel good? No? Yeah? Okay. Plus means I'm going to multiply. Okay? And I can do that because they're both the same. So you can do this a couple different ways. I see that there's a 2 that needs to move up and a half. So I'm going to have log base 2 of x squared plus log base 2 of y plus 1 to the half. So I just moved both of those up. And then since it's plus, that means I'm going to times. So log base 2 of x squared times. Now, 1/2 is the same as the square root of y plus 1. So you can just leave it like that. Or you could do parentheses y plus 1 to the half. But just know, like I've been saying, on a multiple choice test, it could be written either way. But pretty much, they always condense it. So when you're going this way, it's always going to be with exponents and roots. And then this way has no exponents and no roots. You get rid of them. Okay, this one's kind of a doozy. You want to try it?
Yeah.
Okay, you guys do it. So first thing I did was move all of the first, like the out front numbers up to the exponents. Now, when you're doing this, okay, you know PEMDAS, good old please excuse my dear Aunt Sally. A lot of kids mess this up because they are very focused on the fact that it has to go multiplication, division, addition, subtraction. That is wrong. What does it have to be? Do you know?
Multiplication or division.
These go together left to right, okay? And these go together left or right. So as you're doing this, okay, just because my division or my subtraction's first, I have to do that first. Addition and subtraction go left to right. So when I do this, I'm going to get log of 3. This becomes a squared b to the 4th, and then subtraction is division, c to the 3rd. And then I'm going to times it, because that's addition, by the cube root of d. Now, that really has a 1 under it. The cube root of d has a 1 under it. So when you're multiplying, you can kind of just tack it on to the top. It goes in the numerator. So if I write this all out, I can just write log 3, a squared b to the 4th, cube root of d, all in the numerator divided by c to the 3rd. It looks like a lot, doesn't it? But it's not that bad, hopefully. Okay. You guys so kind of live in a good, you're living the good technology life, okay? And we all have these beautiful TI-84s, right? Most of us, okay? So this little, I don't know why they said it's a dirty little secret, but if you hit math and then the letter A, you can do this whole problem easy, right? You type it in, you get math and then the letter A, and then I do log 4 of 12. And that equals 1.7924. Okay? But that hasn't always been the case. When I was in school, we did not have these calculators. We had 83s. Has anybody ever used an 83? One of my students, second hour, has an 83, and her dad's like making her use his old one. And she was like, I can't do any of this because she doesn't have any of the buttons. So she finally just got one. But let's pull out this old handy dandy. If we pull out our trusty,
No phones.
dusty phone, yes, okay? So this is what I used to have. Like I had a calculator that just had a log button. So you can see it right here. Do you see the log button? Okay, and it's right here on this one, log and ln. That's what they used to have. So this change of base formula, it's just for when you don't have the handy dandy math A button. You can break this up and you can simply just do the log of 12 divided by the log of 4. And you will get the exact same answer. So this is kind of pointless for you guys because you have the nice calculator. But if I put in parentheses log of 12 and I divide that by the log of 4 and I hit enter, I get 1.7924, which is the exact same thing. So that's all that is telling you, is when in doubt, you could always do it that way. But you don't have to because you have a nice calculator. Okay. One advantage of expanding functions is seeing what is happening to them graphically, okay? So if I asked you what's happening to this graphically, what would you guys say on the inside there? Horizontal by 1/4. Perfect, okay? Let's say you know that, but that's not one of the choices. That's not one of your A, B, C, or D's. Okay? There's other things because this does, and I'll show you what happens, okay? So if I expand this, I would write log 2 of 4 plus log 2 of x, right? You guys with me?
Yes.
Okay? Now, they want you to try and start to see that this is an actual number. Like if I did this over here on the side, like if I had log 2 of 4 and I set it equal to x, and I do my 2 to the power of x equals 4, it actually, this whole chunk actually equals 2 plus log 2 of x. So instead of a horizontal dilation by 1/4, what also could have happened? It's going up 2, isn't it? It's going up 2. So if you think about that, okay, if I go up 2 and I horizontally stretch it by 1/4, okay, I'm kind of getting it, I'm scooching it in, I'm going like this to it, and it's going up 2. So that's kind of like the same thing that's happening. So those are the same thing, but this might not be on your multiple choices, so you'd have to expand it. So like this one, what do I do with that 2? Move it out front, okay? So I'm going to move that out front, so I get 2 times the natural log of x minus 4. So then what's happening here?
2 times the natural log of x divided by the natural log of 4.
No, you can't break it up because they're in parentheses.
Then it's just being stretched by 2.
Yep, so this is a what? vertical stretch by 2, and
Horizontal translation.
so right or left?
Right.
Right 4. Okay, so this last one is quite a difficult problem. So do you notice in here, we kind of always want it to look like that? Isn't that like the goal in the parentheses, is to look like x minus a number, and then we know if we're going left or right, or if it's x plus, we go left, you know? So does this one have that?
Can you take it out?
Yes, you can. Perfect. So our first step is to factor out a 9. Because then I'm getting closer to a parenthesis that kind of matches my transformations. Okay, because they want me to describe any transformations. So you have to have x by itself. You can't describe a transformation without x by itself. So what is now, this one, what's 9 and 2 minus x? What's happening between those two things? They're being multiplied. So I can add them. So I can do log 3 of 9 plus log 3 of 2 minus x. Anybody know what this is? Yep, because 3 to the x equals 9, so that's a 2. So I can rewrite that as 2 plus log 3. Now, you want to rewrite this
As a division.
because that might mess you up. Like, am I going left? Am I going right? Like, what's happening? You want to take that negative out, remember, from yesterday. And then I want to make this x minus 2. It's still the same, but now I see, like, there's actually 3 things happening. It's going, what? Up 2, perfect.
Right to,
Up 2,
that's over.
and then right 2. And then it's a
Flip over the y-axis.
horizontal reflection.
Yeah.
Okay. Now, it wants the domain and range. Okay. So, here's where it kind of gets a little tricky because you got to think about this. If I were to graph this, okay? If I were to graph this, my normal one looks like that. Do you guys agree?
Yeah.
Okay, so there's my normal one. So I'm starting with B. Remember, I do B, C, A, D. So I'm starting with B. So what's a horizontal reflection? I flip over. So this is what messes kids up. A horizontal reflection means my X values are changing. So if my X values are changing, I'm flipping this way. I'm flipping over the Y, which is weird. Okay? Because you don't flip over the horizontal line. You flip over the Y. And then I go right 2, 1, 2. So that comes to here. And then I go up 2. So let's say that's my graph. And 2 is my asymptote. So what's my domain?
Negative infinity to 2.
Perfect. Negative infinity to 2. And then what's the range always for these?
All of this.
All reals. Good? Good, good?